Good day and a warm welcome. This is your host, Mr. T. Welcome to another Junior Taki production. In this video, we're going to be looking at interpretive questions under functions, grade 10. Let's get straight into it. In the first question, you're told that the sketch below shows f and g. The graphs of f of x is equals to 1 over x minus 1 and g of x is equals to ax plus q respectively. Points A with coordinates -1 is to -4 and points B with coordinates 3 is to 4 lie on the graph of G. The two graphs intersect at points C and D. The line B is drawn parallel to the y-axis with E on F. Show that A is equals to 2 and Q is equals to -2. So we're required to show that the value of A is positive 2 and the value of Q is -2. From theory, you need to remember that your A represents the gradient of your straight line. And to calculate gradient, you say change in Y over change in X. Your Q value represents shifts up or down, or it's your y-intercept. So let's start with calculation of the value of A. To calculate the value of A, I'm going to say A is equals to 4 minus minus 4 over 3 minus minus 1. To simplify that, we're going to get our A value straight away as an A value of 2. So we have proven that our A value is 2. Now we need to calculate the value of Q. We need to prove that it's -2. So we're going to substitute that calculated value of A into the general equation. So we get y is equals to 2x plus q. We then substitute the point A with coordinates 3 is to positive 4 into that equation. And if we do it correctly, we get 4 is equals to 2 times 3 plus q. Simplifying that, we get 4 is equals to 6 plus q. And finally, our q value is a value of -2. So we have managed to prove that A is 2 and q is -2. We move on to 5.2. In 5.2, they say determine the values of x for which f of x is equal to g of x. Two things that I want to point out. The values, plural, that means we're expecting 2 or more values in terms of x. The second thing is that f of x is equated to g of x. So to work that question out, we start off by just equating f of x to g of x. And in writing, we're going to have 2x minus 2 is equals to 1 over x minus 1. So we have equated f of x and g of x. We then move on to simplifying that by moving the -1 from the right-hand side to the left-hand side. And if we simplify that correctly, we get 2x minus 1 is equals to 1 over x. Our LCD is x. If we multiply or remove that denominator, we're going to get 2x squared minus x minus 1 is equals to 0, leading to a quadratic equation. And to solve that quadratic equation, we're going to factorize it first. We get our two factors as 2x plus 1, and the other one will be x minus 1 is equals to 0. Solving for x, we get our x values to be x is equals to -½ or x is equals to 1, proving that we've got multiple values of x. We proceed to the next question. In our next question, 5.3, they say for which values of x is g of x greater than or equal to f of x? So the interpretation of such a question is that g of x, the straight line, has to be above f of x, the parabola, the hyperbola. So the straight line, we're looking for values of x for which the straight line is above the hyperbola. Just to show you graphically, that region that I've marked there, that small region, that straight line is above the hyperbola. Not only that, even from point D going upwards. So those are the two regions for which the straight line is above the hyperbola. Now we just need to find what corresponding x values we've got for those two regions. The first one, we're going to say x is an element of minus half up to 0. We have calculated already, or we know that the value of c ranges from minus half. The second value, and that negative half, we got it from the previous question, where we got our two values at the point of intersection to be negative half, and the other one was positive 1 for D. The second part would be from that 1 up to infinity, making up the final solution for that question. We move on to the next question, where it says calculate the length of BE, the distance BE. Important for you to analyze that question. The point B and point E share the same x coordinate, which has a value of 3. So if you want to get the corresponding y coordinate of point E, the corresponding y value or y coordinate of point E, knowing that the point E lies on the hyperbola, we're going to substitute 3 into our hyperbola. We know that our hyperbola, like I said, is given as 1 over x minus 1. So we substitute the 0.3 into that f of x, which is a hyperbola. And if we do it correctly, we're going to get f of 3 is equals to a third minus 1. And simplifying that, we get f of 3 is equals to minus 2 over 3. Again, that makes sense because the point E lies below the x-axis, and therefore we expect its value to be negative. Now, to calculate the length of BE, it would be a summation of that line BE in blue and that line in green, the summation of those two. But we know that the blue line, which is the distance from the x-axis up to that point, the point B, is definitely 4 units, and obviously the distance between the x-axis to point E going downwards is 2/3 unit. Therefore, we're going to say the length of BE is a summation of 4 plus 2/3, leading to a final answer of, to 2 decimal places, we can say 4,67 units, rounded off. Finally, the last question says, write down an equation of h if h of x is equals to f of x plus 3. So h of x, we know that it's a transformation of the graph of f of x through shifting the graph of f of x by 3 units upwards. That plus 3, it's a constant, implying that it can only affect the q value, and hence it's a case of just saying h of x will be written as 1 over x minus 1 plus 3. Now simplifying that, we're going to get our h of x as 1 over x plus 2 as our final answer. I hope you enjoyed that. Until next time, bye-bye.